Welcome back, everybody. This is our video solution to problem 3 from Superquiz 2. This is a question about the division algorithm. So we get a quick recollection of what the least common multiple of two positive integers is. So that's the smallest positive integer that's a multiple of both of the numbers, say a and b, that you're looking at. And we're going to assume we have some other common multiple of a and b, and we'll call that c. What we want to prove is that not only is the least common multiple the least of the common multiples, but it actually even divides all of the other common multiples. So we're going to prove that this other common multiple, c, that we've chosen is a multiple of the least common multiple of a and b. Okay, and again, the problem tells us we should be using the division algorithm, and who are we to argue? All right, so the division algorithm, so by the division algorithm, there exist unique integers. Okay, we won't really have much use for the uniqueness here, but it's true anyway. There exist unique integers q and r such that, okay, so what are we doing? We're taking c, we want to show that it's a multiple of the LCM. Well, we don't know that a priori, so instead we're just going to, if you like, divide c by the least common multiple, and it will get some quotient, that's the q, and we'll get some remainder, that's the r. And so c will be q times the least common multiple plus r. And we also know that r is some non-negative integer which is smaller than the least common multiple of a and b. Okay, so the division algorithm gives us both of these statements simultaneously. Of course, if c is going to be a multiple of the least common multiple, this r better be 0. So we need to find a way to conclude that r is equal to 0. All right, well, what information do we have? We know that the least common multiple of a and b is a multiple of a and b. So a divides the LCM, b divides the LCM. We also know that c is a common multiple. So c is divisible by a, and c is divisible by b, or if you like, a divides c and b divides c. What we would like to now argue from this is that r is a common multiple. Okay, so this is the claim we're going to make here. R is a common multiple of a and b. Well, this is going to be pretty straightforward because we know that r is equal, well, we just solve this top equation, r is equal to c minus q times the least common multiple of a and b. Now we know that a divides c, we know that a divides the least common multiple. Of course, if it divides the least common multiple, it also divides q times the least common multiple. So a divides the LCM of AB implies that a divides q times the LCM of AB, but it also divides c, right? So we also know that a divides c, and the combination of these two implies that a divides their difference, c minus q times the least common multiple, which we know is equal to r. All right. Of course, there was nothing special about a here. So similarly, b divides r. All right, so this shows that r is a common multiple of a and b. Okay, but r is a non-negative integer, and it is smaller than the least common multiple of a and b. Well, the least common multiple, it's right there in the name. It's supposed to be the least common multiple. Okay, now it is the least common multiple when we say, okay, it's the smallest positive integer, right? So if r is a positive integer, we have a problem because LCM of AB is the least and r is smaller than it. Well, the only way out is that r is not a positive integer, right? R has to be 0. So since LCM of AB is the smallest positive common multiple of A and B, and since R is strictly less than the least common multiple of AB, right? That's coming from the division algorithm. We conclude R equals 0. It's the only way out. R can't be a positive number. So thus, C equals Q times the least common multiple of AB. Hey, that exactly means that the least common multiple of A and B divides C, or C is a multiple of the least common multiple. There we go. That finishes the proof.